YouTube. I'll need that later. Got a little bit of time to spare. It looks like we have one more lecture next week. And there'll be time to submit another skill submission. And then you get to pick the cert you want to go, the Azure cert you want to go for. Yes, after next week, you don't necessarily need to meet again. Well, as a class. And it looks like it's 5:30. We have quite the number of slides to get through. So let me put this bigger so I see that. Have this chat up just in case. Cool, let's get started. Right, so we are in part 3. We're going to do part 3 and 4 this week of module 2, or module 3, I'm sorry. Next week will be parts 5 and 6, and that'll complete the AZ 104, just as always. After that, you'll have time to submit your skill submission. And then module 4 will be up next, where you get to pick the cert you want to go for. Just as with all the other modules, you'll show completion of them and you'll do your skill submission. So technically, after next week's lecture, we won't be meeting like this for the rest of the term, because you'll either meet with me individually to talk about your skill submission, or you'll be doing the final cert and submitting your work. So yes, it is totally possible to be done with this class earlier than the 16 weeks, and that is perfectly fine. So for today, let's dive into parts 3 and 4. Part 3 being deploying and managing Azure Compute Resources, implement and manage storage in Azure, and deploy and manage Azure Compute Resources. Bring up these, because I'll need them. As a reminder from prior sections that we've covered, Azure gives you many ways to store your data, from databases to blobs to tables, you name it. 4 of these, the ones that are highlighted, are given special treatment because they are primitive cloud-based storage services and often used together in the same application. Again, as a reminder of the storage account, is the container that groups a set of Azure storage services together. Only data services from Azure Storage can be included in the storage account. Combining data services into a storage account lets you manage them as a group. The settings you specify when you create the account or any that you change after creation are applied to everything in that account. So deleting the storage account will delete all the data that is stored inside it. A storage account is an Azure resource and is included in your resource group. Other data services like SQL and Cosmos are managed as independent resources and cannot be included in the storage account. As a reminder of your storage account, you have the subscription, the location, performance, replication, access tier, and secure transfer required or virtual networks. Putting that all in mind, you'll think about how many accounts you need for what location, for what type of replication, for what type of tier, and so on and so forth. Other things that will help you determine how many storage accounts you need would be the data diversity, the cost, and the tolerance for management overhead. In choosing your account settings, you always have the big 3, the name, the deployment model, and the account kind. So the name should be lowercase and digits between 3 and 24 characters. The deployment model can be resource manager or classic. The account kind could be blob storage, could be storage or storage version 2. And to create them, as you have seen in all of the stuff we've covered, you could use the Azure portal, you could use the CLI, you could use PowerShell, or even management client libraries. The managed, unmanaged, and local disk storage lets you choose for what you need. You have various disk roles. Can be an operating system disk, can be a data disk. Now, OS disks has a maximum capacity of 2 terabytes. Data disks have 32 terabytes. And you also have temporary disks. All VMs have one for short-term storage and things like swap, really. You can administer operating system disks in the disk page of the Azure portal as shown here. You also have ephemeral OS disks. These are virtual disks that save data on the local VM storage. They have faster read and write latency than a managed disk. It's faster to reset the image to original boot state if you're using an ephemeral disk. An individual VM failure might be able to destroy all the data on an ephemeral disk and leave the VM unable to boot. Since they are local to the host, you don't have a storage cost and are free. The ephemeral disk will work well when you want to host stateless workload like business logic for multi-tier website or a microservice. Your managed disks have a number of benefits, such as simple scalability, high availability, integration with availability sets and zones, support for Azure backup, granular access control, and support for encryption. Unmanaged disks are stored as a page blob in your storage account. They don't scale or have the management features of managed disks. In the portal, you can create them with managed or unmanaged. You can create VMs with managed or unmanaged disks. Once you've created it, then you have to pick the best disk type for your VMs. They have different kinds. So for example, the Ultra SSD has the following performance. And these are all examples, of course. Ultra disk can go from 4 gigs to 64 terabytes. You have the premiums, which are these. You can see the difference between the Ultra and the premium. With premium SSDs, the performance figures are guaranteed. You can migrate any disk to premium SSD at any time as needed. Your standard SSDs will be this, with these performance characteristics. They aren't guaranteed, but they're achieved 99% of the time. SSDs are great. Standard SSDs are great for budgetary constraints or a workload that isn't disk intensive. The standard hard drive, these are not solid states, have a performance of this. And again, these are the cheapest of the groups. They have latencies under 10 milliseconds for write operations and 20 for reads. They are, of course, the slowest, but are the cheapest. So again, it all depends on what you're doing. Is that bytes or bits per second? Bits. Oh, like I said, you have all of these various options. So you can choose different types of storage for different setups. You know, a data warehouse may not necessarily need SSDs or Ultra SSDs. Maybe it needs standard, or maybe it could use an hard drive. You know, or a production database server. Maybe you need that on premium to be quick, versus an admin web server who maybe doesn't need to be as fast because it's not as disk intensive. Picking the right one for your infrastructure is important, not only for the cost, but also the usability. Data availability is usually one of the most important things for a business. So you need to ensure that your data is replicated, that your data is safe, if not one place, at another. For example, you could do local or locally redundant storage, where your data is copied 3 times across separate racks of hardware in the data center inside of one region. This doesn't protect you from data center-wide outages. You also have the geographically redundant storage, or GRS, where data is copied 3 times within one region and 3 times in a second that's paired with it. There are also the zone redundant storage, or ZRS. Copies your data in 3 storage clusters inside a single region. Each cluster is in a different physical location and is considered a single availability zone. Each cluster uses its own separate utilities for things like networking and power. So if one data center experiences an outage, your data remains accessible from another availability zone. These availability zones are within a single region, so it won't protect you from a regional level outage. There's also the geo zone redundant, so you could copy across one region to another. And there's also read access geo zone redundant storage. So you can totally copy around the world. But there is something that was mentioned about the paired regions. Oops, that is the paired regions. So if you are copying, if you want to copy between 2 regions, you can do it, for example, from Asia, you have the East and Southeast Asia. The UK would have UK West and UK South. North America has East and West, so on and so forth. Within the Azure portal, you can switch the replication type as needed. You can also do live migration with ZRS, GZRS, or RA GZRS to avoid downtime and data loss. Azure Storage security features cover things like encryption at rest, where everything is automatically encrypted by storage service encryption with 256-bit AES. While in transit, you should use HTTPS to secure your communication. There is also, give me 1 second to mute that. There we go. There's also the core support, the cross-origin resource sharing, so that web applications at one domain can access resources from a server at a different domain and only get from authorized sources. Of course, if we've talked before at length, using the role-based access control. And of course, auditing, keeping logs and actually looking at the logs. In Azure Storage Accounts, shared keys are called storage account keys. Azure creates 2 of these, a primary and secondary, for each storage account that you create. These keys give access to everything in the account. So obviously, they need to be protected. For security reasons, you should probably regenerate the keys periodically. If someone is able to breach your infrastructure, then regenerating the keys would be something to do quickly. If you're using things like Storage Explorer, then again, regenerate those keys to prevent others from getting access to them. As a best practice, you shouldn't share storage account keys with external third-party applications. If those apps need access to your data, you'll need to secure the connections without using storage account keys. For all untrusted clients, you have the shared access signature that can take that place. You can use service level shared access signatures to allow access to specific resources in your sharing account. For example, uploading certain data or being able to get access. You can use a lightweight service to handle that shared access signature. Never think that by default the rules are all set up correctly. You need to go into the access rules and verify that everything is accurate and secure. You can also use Azure Defender as an extra layer of security intelligence to detect unusual and potentially harmful attempts to access or exploit your storage accounts. They have reports that will tell you about possible attacks on the system and things that you can review and take actions on as necessary. Switching gears to storing and sharing files in your application with Azure Files. That's a little blurry. Azure Files can be used to add or replace a company's existing on-premise NAS devices or file servers. They can help developers store applications and configuration files. They can work for cloud-based apps to efficiently write log files using REST API. You don't have to buy and deploy expensive redundant hardware. You can automate the creation and editing of file shares using PowerShell or Azure CLI. You have the resilience of the Azure platform. All your data will be encrypted, and the shares are cross-platform. There's two built-in methods of data access in Azure Files. You have the direct access as a mounted drive, and you could also use a Windows server either on-premise or in Azure and install file sync to synchronize between local and the cloud. Of course, you'll need to think about redundancy. So once again, comes back to what you need, what you can pay for, and figure out a best solution for your data. And then, of course, after that comes the whole planning of moving data and how that's going to happen using what tools. Because some things may be light and some things may be very heavy. To create and connect storage accounts to be used for Azure File Share, you can do it as example here, creating an account, creating a share, or of course doing it right through the Azure portal. On the right is a picture of the commands you could use to share, for example, with SMB. Securing access would begin by removing SMB version 1, which was used in a variety of cyber attacks. That is the command to remove that feature. You'll need to configure your firewall to allow only specific IP addresses, or doing it by command line, or of course using the Azure portal. But either way, you need to be very specific as to who can have access to that data, restricting by the network. You can also use Azure AD in order to authenticate users to be able to access that data, upload and download as necessary. And of course, you can use snapshots as an extra level of security to reduce the risk of data corruption or accidental deletion. That is always something that we have to be mindful of. So we've kind of covered Storage Explorer being a GUI application by Microsoft that works on any OS, letting you connect to multiple storage accounts, letting you connect to Cosmos DB or a data lake. The storage types being all the ones we cover, from blob to table, queue, files, and data lake storage. Like I said, the program can handle multiple accounts. Connecting to it could be either the URI, the local emulator, a connection string, Azure AD, all kinds of different ways. You could, speaking of Azure AD, in Storage Explorer, you can add an Azure account, select Azure, add a resource via Azure AD, and then provide the information you need. You could connect with a shared access signature and use that way to access data. You could use the storage account name and key, which again, you shouldn't necessarily be using the keys on equipment that you don't necessarily trust. And again, you can use that software to connect to Cosmos DB and data lakes with either the connection string or the URI associated. Azure Import Export will give you a way to export data from Azure storage to an on-premise location. It offers a secure, reliable, and cost-effective method to export large amounts of data. The WA Import Export tool, since it has to be written on a disk in a specific format, it does the drive preparation to handle that data. It'll check a drive and prepare a journal that'll be used by the import job. So it'll prepare the disk to be shipped to the Azure data center. It'll format the drive to check for errors. It'll encrypt the data on the drive. It'll scan it to determine how many physical drives are required to hold the data that's going to be transferred. Create a journal files used for the import and export operations. There are 2 versions of it. Version 1 supports import and export for data blob storage, and version 2 supports data into Azure Files. For export jobs, this service uses BitLocker to encrypt the drive before it is shipped back to you. Microsoft will give you the encryption key. You can use that to access the data and transfer it to your on-premise location. For import jobs, all data must be encrypted through BitLocker before you send the disk to Microsoft. No one will be able to read that data unless you give them the key. So the way it works in exporting, you'll need an active Azure subscription and storage account, of course. You'll need a supported version of Windows with BitLocker enabled. You'll need an active account with a shipping carrier like FedEx or DHL to ship drives to the Azure data center, and a set of disks. So you'll create your job. You'll send the disks over to the Azure Center as identified by that export job. You'll be able to see the job status when the disks are arrived, when the data is being transferred, when they're packaged, and they're shipped off to you. When they get to you, again, you can mount them and use them locally. To import data, you'll need the same settings or the same preset setup as before. You'll need to prepare the disks. Each disk having to be an NTFS volume. Each one has to have a SATA connector with BitLocker enabled. The data can be copied over using a tool like RoboCopy, for example. Then you'll run some commands using the WA import tool to prepare the disk. Then you'll create the job, ship it. You'll see the job status and then receive the disks back from Microsoft when they have finished copying. Again, this is one of those tools that are necessary when we're copying or when we're transferring a whole lot of data at a time. Data that if you had to do it through your internet service provider may probably take way too long to use. Because most ISPs will slow down upload and download may be capped. So a way around it would just be to use this system to copy your data onto physical drives, send it off to Microsoft, and then have it uploaded to the cloud. The Data Box family. Data Box lets you send terabytes of data in and out of Azure in a quick, inexpensive, and reliable way. It's divided into two main groups, the offline and the online data transfer. Offline data transfer allows you to move large amounts of data whenever you have time, network bandwidth, or cost restraints. Online enables a link between your on-premise assets and Azure. Again, this is one of those where you need a ISP who's not going to cap you or slow you down as you transmit your data up. With the offline, you would get a like a USB drive to send data up. Just as with the prior, BitLocker would be used, AES 128 would be used. Data is wiped clean according to the NIST 800-88R1 standard to ensure that whatever data you gave them is secure. And then just like the prior, you're able to track your order as it goes from you to the data center and back. The steps that it takes to use this would be, again, to create an order in the Azure portal, receiving the device from the data center, copying your data, and then shipping it to Azure, and verify that you see it inside of your Azure storage account. Funny enough, there is a data box heavy that is a massive device weighing 500 pounds and arrives on wheels. That is nuts to think about. They have that option. Again, DataBox can be used for things like one-time migrations, bulk transfers, or periodic uploads. For example, like a video that's generated from like oil rigs or windmill farms that aren't necessarily connected to the internet all the time. Disaster recovery, migrating from on-premise to another cloud provider could also do this. Your offline transfers could be a DataBox Disk, or DataBox Heavy. Could use the Azure Import-Export with a network if you want to send it across the internet, if it's not too big. You could use a virtual appliance with the DataBox Gateway. You could use the Storage Explorer, or even the Stacked Edge, which allows or also uses physical devices to transfer into Azure. The Stacked Edge provides capability like compute, storage, networking, hardware accelerated machine learning to any edge location. You also have the Data Factory to organize, move, and transform large quantities of data. You could also script this. Again, choosing the right setup will determine on the amount of data you're going to be transferring. An example would be like autonomous vehicles who capture a lot of telemetry that you would use a data box, for example, to upload to the cloud and then be able to process. Lastly, in this part, Azure File Sync allows you to extend your on-premise file shares into Azure. It works with your existing on-premise file shares to expand your capacity and provide redundancy in the cloud. It requires Server 2012 and later. And it works with anything like SMB, NFS, and FTPS. So like I said, it will extend your on-premise file server, basically turning it into a local cache and putting everything else up in the cloud. Cloud tiering is off, and you can enable it. There are some terminologies that go with this process, like the storage sync service, the sync group, a registered server, cloud tiering, and so on. The high-level process to set this up would be to evaluate your on-premise system. If your OS and file system are supported, you would create the Azure resources. You would install the file sync agent, register it with the service, and make an endpoint. Some possible problems in setting this up would be things like antivirus. who may see this exfiltration of data as a malicious action. Backups, oops, and encryption could also be problems with this system. So definitely ensure that your OS and files are able to handle this file sync. System requirements are Server 2012 R2 and up. In full or core deployments, you need at least 2 gigs of RAM. With all the latest patches, your storage should be NTFS. You can use PowerShell to run the AZ storage sync and do an evaluation, and it'll tell you how ready you are or things that need to get fixed. Of course, you can do this, at least part of this, in the portal, setting up the storage account, setting up the file share, the sync service and group in order to connect the on-premise up to the cloud. To set up the file sync on the Windows server, which would be the on-premise, you'd have to disable, i.e. enhanced security configuration, and then be able to install the agent, register it into that service, and add the endpoint. And of course, you need to test for common problems, like unable to mount the share, maybe port 445 is closed. See why the files or directories aren't syncing, might be invalid file names. Checking the sync to see that the folders are being replicated. You can view the server health and metrics for the storage sync service. You could use Azure Monitor, so you have the storage sync service locally, you have the Azure Monitor in the cloud, you also have event logs, and of course you could use Performance Monitor to see how the system is doing. Any other questions so far? Okay, seeing none, we'll move, as we are in the halfway point, now to part 4. As with last week, I did skip over some of the sections. For example, some of the sections in part 4 were to create a Linux VM, to create a Windows VM. Yeah, we've kind of got beyond that already. So no point in covering that. So we'll start from securing the VM disks. The main encryption-based disk protection that Azure has for all the VMs is the Azure Storage Service Encryption, or SSE, and the Azure Disk Encryption. SSE, the first one, is performed on the physical disk in the data center. If someone was to directly access that physical disk, the data would be encrypted. When the data is accessed from the disk, it is decrypted and loaded into memory. ADE, the bottom one, encrypts the VM's virtual hard disks, or the VHD. If a VHD is protected with ADE, the disk image will only be accessible by the VM that owns the disk. It is completely possible for a service to protect the data using both forms of encryption. So you can think of SSE for data at rest. ADE can also do it at rest. ADE is required for VMs to be backed up to the recovery vault. VMs that already are in existence can be encrypted. If they weren't set up before, they can be. You'll just need to create a key vault. You'll set a key vault access policy to support disk encryption and use that vault to store the encryption keys for ADE. Here's an example on how to configure and manage your key vault with PowerShell to securely store and access those secrets. And that could be anything from API keys, passwords, or certificates. You can, of course, do this through the Azure portal. I would prefer to do it on the command line, only because I feel I go faster by typing than by clicking. If you want to encrypt an existing VM disk, you'll still need that key vault set up. There is a warning before you turn on encryption. Must take a snapshot or a backup of the managed disks. The skip VM backup flag will inform the tool that the backup is complete. Without the backup, you'll be unable to recover the VM if the encryption fails for some reason. So ideally, you want to set up your VMs to be encrypted at the beginning when they're created. But it's perfectly fine that you make that decision after the fact. Just know that you should make a backup in case things go wrong. The first picture shows you the process to enable encryption. This picture shows you the status of it, and it'll tell you whether the disk is encrypted or not. If you need to revert and decrypt the drive, you could also do that as well. If you were deploying several servers at once, and they have a whole ton of settings that need to be done, including encryption, you can totally automate it using the Azure Resource Manager templates. They're all JSON files that you would use to deploy. There are some that you can already use that are available, including on GitHub. When the template is deployed, Azure will show you the list of required input fields that you'll need to enter. And then you can execute it, making life that much easier. You must keep your VMs up to date. You can use the update management to do this. Update management can handle things like the monitoring agent for Windows, PowerShell desired state configuration, automation hybrid runbook worker, and the Microsoft Update service. This is supported on Windows Server, anything 2008 and up, CentOS 6 and 7, Red Hat Enterprise 6 and 7, SUSE Linux 11 and 12, and Ubuntu 14, 16, and 18. Of course, just because you create it doesn't mean it all works. You always have to verify. You'll verify that the components that are being used to perform assessment and update deployments are working with the 4 that I just mentioned: the monitoring agent, desired state configuration, hybrid runbook worker, and WSUS. It'll do a scan for compliance. The compliance scan is by default. It does every 12 hours on a Windows computer and every 3 hours on a Linux. It'll take about 30 minutes to 6 hours for the dashboard to display updated data. And of course, because updates don't just end with one, there'll be recurring updates, so you can schedule those as well. The Azure Resource Manager is the interface for managing and organizing your cloud resources. It's like a way to deploy the cloud resources. Their benefits can be by using templates to improve consistency, to help express complex deployments, to reduce manual or error-prone tasks, using code, infrastructure as a code. That way you have a paper trail that can be followed. Templates, especially those that work, are easy to reuse, and they're linkable. So here's an example of what's in a resource manager template. You can specify what values are configurable when the template runs. You can set variables, like networking, for example, along with what resources will make up that deployment. The guide has a quick start template for both Windows and Linux, along with adding resources to templates for Windows and Linux. When you go through it, I suggest checking both out and seeing how it will improve or cause more mayhem to your current setup that you're using in your skill submission. This would be a simple item, a freebie item that you could use in your skill submission. Now, since we're talking about templates and being able to replicate quickly, an item that I saw in the next section is generalizing images. These are great to scale up, another way of templating a system. If you're using a local VMs that you want to be able to duplicate quickly, generalizing VMs is the way to go. In the case of Windows, you would need to run sysprep, which is a destructive process, and you can't easily reverse the effects, so you'll need to back up a VM first. You'll run sysprep, which is hiding in System32. It'll give you some stuff to do. You can also call it through PowerShell. You can. They also have, for Linux, the WA agent. And again, this will do things like remove the most recently created user account, remove public SSH keys, reset the host name, and do cleaning log files in order to create a generalized VM that can be used to turn into an image that then you could use to replicate over and over as necessary. So you kind of have your golden image with all the settings you want. It just so happens that it'll have a few of those settings removed, like the username and host name and whatnot, but that's on purpose so that it can be replicated quickly. So you'll capture that image, and then you'll be able to create off of it. Again, here's the instructions. If you wanted to create a VM from a generalized virtual machine. Or create a new VM off of a generalized image. You can create VMs from VHD snapshots as well. And then there's the picture on the left on how to do that. Now we've covered what a virtual machine scale set is. Here is the command if you wanted to manually scale a VM set. Of course, you can have it set up to auto scale, which would be the more preferred. That way you don't have to manage it. You could also do it schedule based as well, to replicate that on certain times and days when you know you're going to get more traffic. Now you can make scale rules from the portal. So when something is greater than a certain amount of usage, or whatever events you want to set up, and then have it create more in the set. You can also install and update applications in the machine sets so that they're all up to date together by using JSON and Azure CLI together. So from version 1 to version 2, it is pretty straightforward on the items you need in order to update a machine set. The DSC, the PowerShell desired state configuration, is a declarative management platform that is used to configure, deploy, and control systems. A declarative programming language separates intent, what you want to do, from execution of how you want to do it. When you want to create a share on Windows Server, you could use this command. The problem with this approach is, yes, it's easy to understand, but you might run into problems. For example, if this script runs multiple times, or if the user 2 already has full access rather than read-only access. PowerShell will need some logic and error handling. If the share doesn't exist, it'll need to be created. If the share does exist, then there's no need to create it. If user 2 exists but doesn't have read access, you can add read access. So you can make it a little more complex like that. But if you're using DSC, it's going to look a whole lot better. This module tells DSC how to check the state for a file share. The resource kit has over 80 modules that you can use, even one for installing an IIS site. There's a local configuration monitor, which is a component of the Windows management framework that you could use. It has 2 nodes, the push mode, which is shown here, An administrator manually sends or pushes the configuration towards one or more nodes. There is also the pool mode. A pool server holds the configuration information. Each node pools the server at regular intervals, like 15 minutes, to get the latest config details. Each node has to be registered with the pool service. They both have their advantage. It all depends on the infrastructure that you'll be using. Lastly, there's a short introduction to Kubernetes. So a few definitions and a quick tour of Azure Kubernetes Service. A container is an atomic unit of software that packages up code, dependencies, and configuration for a specific application. Containers allow us to split up monolithic applications into individual services that make up the solution. This re-architecting of applications will enable us to deploy separate services through containers. So if you were tracking like a website that includes map and information about assets being tracked, or data processing service for information of tracked vehicles, or even an MS SQL database for storing and tracking user information, to scale all that out, it would be a nightmare. And how do you figure out how to do all that together using the right OSs, using the right tools? It can get crazy. Containers are immutable. The unchanging nature of a container allows it to be deployed and run reliably with the same behavior from one compute environment to another. Containers are lightweight. They are smaller than VMs. The image contains both the OS and the application you want to run. In contrast, the containers don't need an OS, only the application, since it relies on the host OS for kernel-specific services. They're less resource intensive. And containers are fast to start up. They can be up in a few seconds. Container managements, they are a little tricky. Containers have distinct life cycles. They're deployed, started, stopped, and destroyed as requested. So deploying, updating, and monitoring and removing have many challenges. That is where the Kubernetes system comes in, because it does automatic deployment, scaling, and managing of the workloads. It abstracts away complex container management and provides us with declarative configuration to orchestrate containers in different compute environments. This basically gives us the ease of use like platform as a service or infrastructure as a service. Kubernetes is not a full platform as a service offering. It operates at the container level and offers common set of platform as a service features. It's not monolithic. It's not a single application that is installed. Aspects such as deployment, scaling, load balancing, logging are all optional. You're responsible for finding the best solution that fits your needs. Kubernetes does not limit the types of applications that can run. If an application can run in a container, it can run on Kubernetes. It doesn't provide middleware, data processing frameworks, databases, caches, or cluster storage. These items are run as containers or as a part of another service. A Kubernetes deployment is configured as a cluster. A cluster consists of at least one master machine and one or more worker machines. For production and deployments, the preferred master configuration is a multi-master high availability deployment with 3 to 5 replicated masters. These machines can be physical hardware or VMs. So Azure Kubernetes Service manages your hosted Kubernetes environments and make it simple to deploy and manage containerized applications within Azure. At its core, an AKS cluster is a cloud-hosted Kubernetes cluster. AKS will streamline the installation process and take care of most of the underlying cluster management tasks. You generally have the two options to create the cluster. You could use the portal or the CLI. Both will require basic information like the cluster name, the version to install, DNS prefix of the master node, and initial node pool size. Azure Service Creation Workflow will create a cluster using default configurations. It'll take a few minutes, and once complete, you can change any of the default cluster properties. AKS supports the Docker image format in order to develop environment or create workloads. So you could use the Kubernetes command line or Azure CLI to manage your deployments. It also uses things like Helm, Draft, or Visual Studio Code. Any questions? Seeing none, we'll continue working through these two parts and submitting your proof of completion. As always, if you feel like going ahead and completing Module 3 and you have your skill submission, go ahead and meet with me. If you're all done with AZ 104, awesome. Go ahead and move on to Module 4.